Good morning, everyone. I'm Jayshua Garabato. Today, we're about to discuss Pascal's principle. First, I'll introduce you my content. First is the introduction. Second is explanation of pressure and force. Third is definition of Pascal's principle. Fourth, formula for Pascal's principle. Fifth, application of Pascal's principle in hydraulic systems. Sixth is examples of how Pascal's principle is used in everyday life. So let's start. Pascal's principle, also known as Pascal's law. In 1653, the French philosopher and scientist Blaise Pascal published his treatise on the equilibrium of liquids, in which he discussed principles of static fluids. States that when a change in the pressure is applied to an enclosed fluid, it is transmitted and diminished to all portions of the fluid to the wall of its container. Explanation of pressure and force. Pressure and force. Pressure measured in pascals is the force exerted over an area. Understanding the relationship between pressure and force is crucial in grasping Pascal's principle. Force-area relation. The understanding of how force is distributed over a specific area helps comprehend the impact of pressure on fluids and solid objects. Other explanation of Pascal's principle: a force can be push and or a pull. When a force is exerted on an object, it can change the object's speed, direction of movement, or shape. Pressure is a measure of how much force is acting upon an area. Pressure can be calculated using equation pressure equals force over area. Definition of Pascal's principle. First is undiminished transmission. Pascal's principle states that a change in pressure is transmitted undiminished in an enclosed fluid and to the walls of its container, regardless of the size or shape of the container. The second is hydraulic power. It forms the basis for hydraulic power, enabling the creation of the powerful systems and machines essential in the various engineering applications. Other definition of Pascal's principle. A Pascal's principle in fluid, gas, or liquid mechanics statement that in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. The principle was first enunciated by the French scientist Blaise Pascal. Formula for Pascal's principle. The formula for Pascal's principle relates the change in pressure to the applied force and the area through which the force is applied. Mathematically, it is expressed as P is equal to F over A. So, P stands for pressure, F stands for force, A stands for area. Application of Pascal's principle in hydraulic systems. So there are three application examples in hydraulic systems. So these are my examples. First is hydraulic brakes. Pascal's principle is the basis for hydraulic braking systems in vehicles, ensuring efficient transmission of force to the braking mechanism. Second is hydraulic lifts. Hydraulic lifts commonly used in car services stations utilize Pascal's principle to lift heavy loads using a small force. Third is hydraulic press. Hydraulic press is industrial equipment like hydraulic presses leverage Pascal's principle to generate high forces for various manufacturing processes. Examples of how Pascal's principle is used in everyday life. So, I have two examples. First is automotive systems. Braking and lifting systems in cars and car service stations rely on Pascal's principle for their efficient operations. So, as you can see at the screen, that's my example of automotive systems. Second is industrial applications. Manufacturing processes such as stamping, pressing, and forging utilized hydraulic machinery based on Pascal's principle. So that's all for today, guys. I hope you learned something. Thanks for watching.